Hello friends, today I am now going to discuss op amp, that is operational amplifier. That is operational amplifier. Yes, I am going to start a new series on op amp. So let's start discussion. First of all, what is op amp? Actually, when someone asks you what is op amp, then you can say that it is an IC chip. IC means integrated circuit chip. IC chip which can be used to perform one, comparison. It can be used to perform comparison. Two, amplification or addition. Amplification or addition. Or you can do subtraction also. You can do subtraction. And by the use of op amp you can do multiplication, division also. We will know about that in our next videos, that operations. So actually op amp, another type of op amp actually use another types of work, that is for waveform generation. So that's our basic things about op amp, that it is an integrated circuit chip that is used to perform comparison, amplification, addition, subtraction, multiplication, waveform generation. Now op amp, basically op amp, there are two types of op amp, that is open loop op amp, and that is one is closed loop. Open loop, one is closed loop. So what are they? What are open loop op amp and what are closed loop op amp? Open loop op amp is that open loop op amp is that without feedback. The op amp that is without feedback. Now here you can ask me what is feedback. Okay, wait, I will say you that about that. Without feedback we can comparison, we can do what kind of operation by the help of open loop op amp, that is actually without feedback we can do comparison. This operation we can do. So by the help of open loop op amp we can do comparison. And for closed loop op amp, there are two types: negative feedback op amp, or another is positive feedback op amp. Positive feedback closed loop op amp. So closed loop are generally two types: negative feedback and positive feedback. Negative feedback means negative feedback. What are the operation of negative feedback op amp? Negative feedback op amp, actually their operation is amplifying, that is their amplifier, that is their amplifiers. And positive, what is the operation of positive feedback amplifier? Positive feedback op amp, positive feedback closed loop op amp, that is their oscillator. Yes, positive feedback open loop op amp, positive feedback closed loop op amp, their oscillator. Now I'm going to discuss about the characteristic of op amp. That means what its property and what its diagram, etc. Characteristic of op amp. So generally, how can you draw an op amp? Whenever I will draw an op amp by this way. So firstly I am telling in here V1. Let me erase one portion. Here V1, here V2, here positive V saturation, here negative V saturation, here V output. Okay, so now I'm going to discuss what are the actual thing. So this is a diagram of an op amp. So in this case, here V1 where you can see that plus sign, that is non-inverting end, and in this case where you can see minus V2, that is inverting end. That means in that minus sign, here V2 is inverting voltage, inverting input voltage, and in the plus sign V1 non-inverting input voltage. This is output voltage, and this is saturation voltage, V saturation, and this is positive V saturation. That means after that no voltage will be taken as an input, that is V saturation, and here minus negative V saturation. And this plus side is non-inverting, negative side is inverting. V1 is inverting input non-inverting input voltage, V2 is inverting input voltage, and this is output voltage. Okay. So what are the properties of that? So properties of that, we can say that first property, input resistance of an op amp is ideally infinity. Ideally input resistance of an op amp is infinity. Yes, input resistance infinity means how can we show that? We can show that when I'll draw an op amp. When I will draw an op amp, here I am drawing an op amp. Here that is in the negative end V2 inverting input voltage, in the positive end V1 non-inverting input voltage. Here I2 current is going, here I1 current is going. Here V output, input resistance means here at input this side R equals resistance is infinity. That means here you can see nothing. That means wireless, that is broken. That means I am erasing that portion. Here V1 is, here V2 is coming, here V1 is coming. That means inside that V1 and V2 nothing is there. That means op amp is, input resistance of an op amp is ideally infinity. And at the output, resistance is 0. So what we come to learn here, we learn that at the input portion resistance is infinity, and output portion of an op amp resistance is 0. That is a property of an op amp. That means input resistance is infinity, output resistance is 0. Okay. And another property, input current as input resistance infinity. Input resistance infinity means input current of an op amp. I am considering ideal case. Always consider ideal case of an op amp. Has input resistance infinity means what? Input current will be 0. Input current will be 0. That is for an ideal op amp, input resistance infinity, that will make input current 0, output resistance of an op amp 0, and the gain. What is the gain formula of an op amp? Gain formula of an op amp is gain equals output voltage V0 divided by input voltage Vin. Vin means what? You can say V0 by difference voltage output, VO by V0 not, we can say actually say VO or V output. That means gain formula is output voltage by input voltage or V difference. What is V difference? Actually V1 minus V2. That you have seen that portion, non-inverting and input voltage and inverting and input voltage, that thing. Now one interesting thing I'm going to do, ideally, another property is ideally gain of an op amp should be infinity. Yes, ideally gain of an op amp should be infinity. That means what? That means let me erase it. That means V0 equals, if I do A into V input. V input means V difference. If I do V1 minus V2, that means A is infinity. A is infinity means what? V0 equals infinity into V1 minus V2. Now from this case, three things can come. Yeah, three cases can come. Three cases, what are they? So we are getting for out gain, for infinite gain, V0 equals infinity into V1 minus V2. So three cases are coming. What are that three cases? V1 greater than V2. If V1 greater than V2, V1 less than V2, three cases are most possible case, and V1 equals V2 from there. So here, if we can see, for V0 equals infinite into V1 minus V2, here if V1 greater than V2, for V1 greater than V2, V0 is plus infinity, that is positive V saturation, that is positive saturation voltage. Positive saturation voltage. And for V0 infinite, V1 minus V2, V1 less than V2. For V1, another case, V1 less than V2 case, V0 equals minus infinity. That is a case of negative V saturation. So two cases we saw. That is V0 for V1 greater than V2, we are getting V0 equals plus infinity, that is positive saturation voltage, and for V1 less than V2, we are getting V0 equals minus infinity, that is negative saturation voltage. Yeah. And another third case is for V1 equals V2, output voltage V0, infinity into 0, that is not possible. That means what? Because 1 by 0 into 0, that means undetermined. That means for the case 3, V1 equals V2, then output is undetermined. Yeah. So what you can see from here? You can see an important things from here, that output of an op-amp lies between V saturation less than equals V0 less than equals plus V saturation. So output of an op-amp lies between negative V saturation and positive V saturation. That is the thing. So what is the characteristic curve of an op-amp? We can draw. So here, if we draw V0 versus Vi, V0 versus Vi means here we draw positive V saturation in this axis. Here V1 equals V2, and here V1 greater than V2. V1 greater than V2, we are getting positive V saturation. Na? So this portion V1 greater than V2, and here V1 less than V2 for this case, we get negative V saturation. That's it. So we can draw clearly for that infinite gain what we are getting for three different cases: V0, Vi, positive V saturation, negative V saturation, positive V saturation V1 greater than V2, negative V saturation V1 less than V2. So these are the case if we consider gain of an op-amp ideally infinity, then we got these three cases. So if we do a thing, then you can if we do an example, you can be clear. So another thing is, if we do an example, that is here it is an op-amp. Here 1 volt DC is given, 2 here minus, here plus, 2 sin t plus 15 wait daran ekটু. So here an op-amp, minus is here, plus is here, 2 sine t, 1 volt DC plus 15 V voltage saturation minus 15 voltage saturation. So sine t value lies between plus 1 to minus 1. So sine t maximum value when? Sine t maximum value is for 1. For 1 sine t maximum value. So sine t max, that means positive maximum, here it is V1, here it is V2. So V1 maximum value is 2 volt and V1 minimum value, sine t minimum value is minus 2. So 2 sine t becomes minus 2 for minimum voltage. Okay. So I'll draw an output versus input for this graph. So for this op amp, in my next video, I will draw, remember, I will start my next video from this portion. Here it is an op amp. Here it is 2 sine t. And here it is 1 volt DC. Here it is plus 15 volt saturation, here it is minus 15 volt saturation. So for this op amp, for this case, in my next video I will start from here. We will draw output versus input graph. There you can see a clear concept about the output versus input graph of an op amp. So for today, thank you, bye bye, and thank you for your patiently watching my video. Bye.